So in 3.4, we're going to graph linear inequalities in two variables. So I'm going to back up a little bit, just talk about equations for a second. So we have linear equations that come in the form, the standard linear equation form is ax plus by equals c. So that's in two variables, x and y, and we have that. We graph them, we find solutions, and they graph to be lines. So if you're like, oh, I don't remember graphing, we're going to review the graphing. So it'll come up naturally in what we're doing in this section. But that was just linear equations and what we do with those. A linear inequality, well, it's going to be very similar. It's going to be ax plus by, and then it's either going to be, greater than c or less than c, or greater than or equal to c, or less than or equal to c. That would be the standard form for different linear inequalities, okay? Now when we have a solution, so let's say we have something like, 3x plus 2y is less than 7. And say we want to put in a solution. A solution is going to be an ordered pair, an x and a y. So maybe I pick the point 5, -2. Okay? So if I were to graph that, I would go to the right 5 and down 2 and be like a point right there. And maybe I want to know if that point is a solution to this inequality. To do that, I plug in the 5 for x, and then the -2 for y. This is my x, this is my y. It's called an ordered pair. And I plug those in, and I see if I get a true statement. So 15 plus a -4 is less than 7. So I get 11 is less than 7. So no, my point was not a solution, not a solution. And I'm talking about that point. There's other points that are solutions, but the one I picked wasn't, okay? All right, so that's what they want us to do on this first problem, first example. It says determine whether each ordered pair is a solution to the inequality. So here's our inequality. It's not in the standard form. It's more, you might be used to the form y equals mx plus b. Hopefully that brings back a happy memory. So it's similar to that form. It's just an inequality though. But to see if it's a solution, we're going to do what we just did a minute ago. This will be the x, this will be the y, and we're going to put in 0 for y, 0 for x, and so we get a statement, 0 is greater than -3. Now don't be hasty when you're working with these statements because it's really easy to make a mistake. So you have to stop and think, is 0 greater than -3? Yes. Or you can put true. And so, yes, it's a solution. So it says determine if it's a solution. Yes, it's a solution. A solution. Okay, so then we go to the next ordered pair, 4, 9. So again, this is the x, this is the y. We put in 9 is greater than 4 minus 3. Okay, 9 is greater than 1. Yes, it's a solution. Yes, I'll just put yes. Okay, the next one. So now we have, this is our x, this is our y. We have 1 is greater than -2 minus 3. So is 1 greater than -5? So I have to do the calculation, -2 minus 3. Is 1 greater than -5? Yeah, that's a solution also. Okay, so far all three have been solutions. Now we're going to put in -5 for x and -3 for y. And so we'll have -3 is greater than -5 minus 3. So -3 is greater than -8. Let's see, make sure I wrote everything right. Is -3 greater than -8? Yes. You have more money in the bank if you have a -3 than if you have a -8. We don't have any money, but don't think of it that way. Okay, so -3 is closer to 0 than -8, so therefore -3 is a bigger number. You can do that on a number line. Here's 0, here's -3, say, here's -8. The numbers get larger as you move to the right. Okay. So our last one, 5, 1. So we're putting in a 5 for x and a 1 for y. So we get 1 is greater than 5 minus 3. 1 is greater than 2. No, 1 is not greater than 2. So that point is not a solution. The other ones work, but not that one.